All right, good. Is it still morning? I think it's still morning. Good morning, everybody. So this is a little bit of a change in gears from an academic study, or all the academic studies we've seen, to commercial application. So my name is Matt. I'm CTO and co-founder of Kestrix. We're a startup based in the UK, focused on really diagnosing buildings at scale. And I'm going to emphasize the scale point a lot in this presentation. So you may already know that there's 100 million homes that need retrofitting across Europe, including the UK. That is a lot. And that all needs to happen by 2050. So what we are doing as a big starting point in our developments within Kestrix is thinking, how can we get to scale as a prerequisite? And as we've already mentioned, and this is a little bit hyperbolic, so apologies for this audience, but there is no reliable and scalable way of assessing buildings, right? We've got EPCs and their equivalent across the whole of Europe, but we've already heard that there's a massive performance gap between those and reality. So how do we solve those? And we've also found that talking to customers who are trying to evaluate buildings at scale, the EPCs which they rely on today are causing a lot of challenges, or they're just not sufficient. So the Director of Sustainability at Peabody, who are a social housing provider in the UK that own a little over 100,000 units, they complain that energy efficiency data is not reliable enough to plan and validate retrofits for their portfolio, and they need to do manual surveys which are slow and cost a lot of money. And when they're doing their planning, they're only sampling those properties, and as we know, every house is different, and their sampling methodologies don't tend to work, and they get surprises when they get into the field. So our question is, well, what if there was a way to quickly measure heat loss from a home without going inside? So what we are doing at Kestrix is we are using heat loss mapping, so using thermal imaging at scale, together with AI, which I know is a term bandied around a lot these days, to generate energy efficiency plans, and we're aiming for that, to do that at city scale. So every house individually modelled at scale of a city. So how are we doing that? Well, we scan whole neighbourhoods at the moment using thermal drones. We're doing that at night, at least 3 hours after sunset. We're also doing full visual scans as well during the day. And then we pull all of that imagery. Currently, we've got about 200,000 images in our database to build these 3D heat loss models. So we're building 3D out of the visible images. We're recognizing surface materials so we can compensate for things like emissivity. We're doing all that in 3D, so we can understand the geometry for the thermography, but also then for the building physics modeling as well. Pulling insights out of that, and then we're sharing those with our customers through a user interface. So I mentioned AI is, of course, a term used a lot. We're not using LLMs. So we are applying predictive models and heuristic simulations, both in terms of simulating the thermal radiation environment. You might be aware that when you're taking thermal images, you've got reflections happening, you've got different surfaces emit differently. We're compensating for those things. And then we're just starting our journey to build the prediction models for U values out of that data as well. So ultimately, what we're trying to help our customers get to is going from a 2 or 3 hour survey with all of the desk work to just a couple of minutes. This doesn't have to be as accurate as a co-heating test, though. We are working at hundreds of thousands or even millions of properties eventually, and so we just need to be more trustworthy than the EPCs that we have today. Which is maybe a low bar, right? But let's start there. The benefits of doing that mean that large landowners or other stakeholders in the built environment, whether those are mortgage lenders or energy companies, can prioritise where are they going to take action, build incentives, finance, deploy workforces and that kind of thing. We can actually start to do some high-level planning and sort of manage supply chains of whether that's windows, insulation and that kind of thing. The very visual nature of what we're doing, a very tactile 3D model, gives us an opportunity to engage with residents in a way that they can really understand rather than just presenting them with charts and numbers. And then ultimately we want to be able to verify as well. So come back the winter after and see, did the changes that were made to these properties actually have an effect? We've already mapped over 1,000 properties in last winter, and these are a bunch of the companies that we're working with, mostly in the social housing space right now, with a notable addition of the National Trust. And we've got a collaboration which I think there's a press release going out later on this week with EDF, specifically around DESNZ's Heat Pump Ready programme, and others in the pipeline as well. So we've already got a decent amount of traction. Just to give you a sense of how we envisage this growing. So I mentioned that we've got over 1,000 properties already identified. Over the next 3 years, we've got a trajectory to get us to around 1 million buildings by 2027. So by the time this project concludes, we hope to have a 3D thermal data set of around 1 million properties. Mostly in the UK, but we're expecting to do some pilots throughout other parts of Europe as well. So just as a conclusion, really, I mean, like, if we don't understand how heat is being lost at scale, it's really difficult for organisations to understand where to start and what is indeed possible in terms of transforming our cities. We're working a lot around, can we do heat pump assessments non-invasively like this? Can we help heat networks plan how they're going to roll out over existing estates? And then finally, I've already mentioned around validation. So the relevance to, of course, this project is that we are a novel approach to measuring HTC at scale. And we're interested in being a target for the validation methodology that this group is coming up with. I thought I'd just jump to a little demo just to see where we are at right now, just to give you a sense of what we're doing. So here is a house. This happens to be a Cussin system build somewhere in Rugby in the UK. This is a fully movable 3D model. This was one of about 400 properties that we collected within the same drone mission. So again, going back to scalability, we were able to create these high-resolution 3D models from, I think it was 24 hours worth of data capture for 400 houses. Now that's not going to get us to the 100 million homes just yet, but it's, it's on the trajectory of that scale. And then what we've got is we've got a thermal overlay. Oh, the resolution of that's not very good on that screen. Anyway, I will zoom in a bit. So you can see, and we're working on sort of refinements of these, but you can already see how, this is a steel-framed system build structure. So there's actually, no, you actually can't see it on this, but there are warm vertical lines, which are actually the steel structure conducting heat through the walls. And we're working to sort of quantify that at the moment. And then if I just go back to RGB, we've also got full dimensions and geometry. So when it comes to actually making calculations, not around the physics simulation, but also then quantity surveying on how much is it going to cost to actually fix this. We've got reasonably accurate measurements, again, at scale in order to come up with those budgets. So that is basically everything I wanted to cover. Thank you very much.